So in the last class, guys, we discussed about mirror formula, right? Mirror formula was basically what? 1 by v plus 1 by u is equals to 2 by r, and which is equals to 1 by f, right? Yes or no?
Yes, sir.
Now you understood from where this f is equals to r by 2 comes. I told this particular thing, when u is infinity, then v is equals to f. Yes or no? So you'll just put this over here, then automatically you'll get the answer. This f is equals to r by 2 comes from this particular knowledge of definition, by the definition of principal focus. So by the definition of principal focus, this comes f is equals to r by 2, and you put these values in this formula, then you get this. Okay. Anyways, so this was your mirror formula. I told you about this particular thing. Use mirror formula with sign convention. Yes or no? With sign convention, right? So in the last class we proved this particular thing. Also, if sometimes people will give you direct questions, or if you want to use this, you can use this, just like your 10th grade classes, or you can modify it a little bit. Can you see, if 1 by v plus 1 by u is equals to 1 by f, then I can write f is equals to some alternating form of mirror formula. You can write 1 by f is equals to 1 by v plus 1 by u. From here, v is equals to v, or u into v upon v plus u. Okay, you can either write this. Similarly, 1 by v will be equals to 1 by f minus 1 by u. So v will be equals to u minus f. Sorry, and then you'll reciprocate also. So, and similarly, if u has to be calculated, then u will be equals to f into v. Okay, so these are your alternating formulas of. Don't need to remember this, although remember only one. 1 by v plus 1 by u equals to 1 by f. This is the main mirror formula, and we have derived this particular thing. So anyway, now let's write the next heading, which is called as lateral. Achha, before and making you the derivation for lateral magnification, let me sign conventions. Okay. For numerical problems, we'll use some sign conventions. And what are the sign conventions? We'll not use the grade 10th one. We'll use some of the points of grade 10, but we'll use our own convention, right? First point is, all the horizontal distances are measured
Whole.
from. Are tell me, from where? All the
From the
horizontal distances are
pole.
measured from
From the pole.
the pole. All the vertical distances are measured from
Principal axis.
the principal axis. याद है?
Yes, sir.
And use the normal convention generally. Use any convention which you want. Accordingly, for example, if I want a convention in which this is positive, then this will automatically become negative. This is positive, this is negative. Generally, I try to use this one so that it is much more easier to remember. Normal plus x plus y minus x minus y. The normal Cartesian convention. I try to use this, but you can use up to yourself. It's up to you. You say positive is this side, negative is this side, and positive is this side, and negative is this side. It's up to you. Whichever convention you want, you can use it on your own. No problem at all. But please remember, once you decide a convention, keep the convention same. Note, once the convention is decided, generally take this one, है ना? Once the convention is decided, keep the convention same for all the optical instruments. This is from experience, है ना? In a particular problem. I'll give you questions which are based on this concept. It's like, I'll give you two or three combination, two or three mirrors in combination, right? But not in combination, like one mirror is placed over here, one mirror is placed over there, and then I'll ask you to find the final image if the first reflection take place from that mirror, this mirror. Accordingly, we'll solve the question. But please remember, if two or more mirrors or lenses or anything is included, optical instrument is included, then never ever change the sign convention for, okay, let's say, sir, we have come from this to this, then there is a different sign convention for that. No, never. If the sign convention is decided, keep it same for all the optical instruments in a particular problem. Either. ठीक है?
Yes, sir.
Now let's talk about lateral magnification. What do you mean by lateral magnification? Lateral magnification is basically the size. Do you remember the normal magnification you have heard? What was lateral magnification? It is the ratio of height or size of image to that of the object. So always remember, guys, lateral magnification is equals to size of object, and it is equals to hi by ho. ये सबको पता है? Yes or no?
Yeah.
Yes.
चलो, let's try to derive this particular thing. Let's say I'll try to use the sign convention as well. Till now, whatever mirrors you have seen, the ray is always coming from left. No, I don't want the ray coming from left. Let's take the ray coming from right. Okay, like this. So let us say this is your incident ray, and let's say this is where the object is placed. Can you see this object, guys? Object is OA. Is the object? Yes or no? Yes or no, people? Now let's say its image forms at here. So this is A dash and this is I. So A dash is basically what? The image, right? Can you see this is the incident ray, this is the reflected ray, it is incident at the pole. So these two angles will be equal. Yes or no? The angle of incidences will be equal, right? This distance is basically V and this distance is basically U. Yes or no? Image distance, object distance. The height of the object is basically how much? HO. And the height of the image is HI. Yes or no? Now tell me, are these two triangles, triangle PI A dash is similar to triangle PAO? Yes or no? और इसको ऐसे में लिखते हैं PO. Yes or no? RHS congruence? No, RHS 1 added to what kind of similarity is it? Side angle side, है ना? नहीं, angle. Whatever it is, I don't care, man. So since these two triangles are similar, can I say here in this big triangle on the small triangle, in the small triangle, can I say tan alpha is equals to IA dash divided by PI? Can I say this? And similarly, tan alpha in the bigger triangle will be equals to AO upon PO. Yes or no? Now using the sign conventions, which sign convention do you want me to take? Tell me. Whatever you will say, I'll follow. Tell me, what shall I take it here? Shall I take it positive or shall I take it negative?
So positive.
Okay, let's take positive over here. So this will automatically become negative. Do you what do you want me to take? Here downwards negative or
Negative.
positive? Downwards negative. No, I'll take positive just to be try my convention ki whether any convention works or not, right? So I've taken this positive. Now I a dash. I a dash. Can you see? I a dash is in the in the positive direction. I a dash is downwards, right? Vertically down, and downwards are taken as positive. So I'll write plus hi. Yes or no? Are you getting my point, guys? Plus hi divided by. Uh, can you see over here pi? What is pi? बाला गेट बंद कर दे भाई प्लीज. गेट बंद कर दे. गेट बंद कर दे भाई. So negative. Can you see over here? Object's height is basically ho. So can you see negative? So can I write minus of ho is equals to now ao. What is ao? Sorry, my bad, my bad, my bad, my bad. What was that? Pi na. Pi is basically what? Can you see? Pi is basically the image distance. So can you see in the positive
V.
direction v? So plus v is equals to AO, the negative HO. So can you see, guys, I'm just following both the convention which I have decided. Although you said कि sir यहाँ पे positive ले लो, यहाँ पे negative ले लो, it doesn't matter. If your knowledge of conventions is clear, just like the way you used to do in vectors, then this is the, and can you see V will be plus, right? अच्छा, suppose. Let me change the convention a bit. Let me take this positive and this as negative. This as negative. Oh, sorry. Oh, and this as negative. Right? I have taken this convention. Suppose. So, can you tell me what will the equation become? Guys, can you tell me what will this equation become? Equation number one. I a dash. Can you see? I a dash is downwards and downwards is negative. So I'll write minus hi. फिर उसके बाद since I have taken this distance as negative towards the right as negative, so even this v will be negative. So divided by minus v is equals to ho will be above the principal axis which I have taken as positive, so plus ho. And since again u is towards the right and right I have taken as negative, so minus u. Can you see, guys, when you solve both the equations, can you see over here from there will be everything is plus plus plus, only this minus sign is there. So hi by ho यहाँ से भी if I calculate, so will it be equals to minus of v by u? And from here also, can you see negative 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 will get cancelled, this negative and this negative will get cancelled, this negative will remain, ho will come down, v will go over there, and again can you see from any possible convention which you take, your final answer will be this only. So magnification का formula जो होता है वो hi by ho, and that is equals to minus of v by u. This magnification formula is only for magnification formula for spherical mirrors only. Is this clear?
Yes, sir.
Is
Yes.
this clear, people? Is this clear?
Yes, sir.
Sorry. Now let's start to do some questions. I told in the next class we'll do questions and complete this whole thing. I need to teach one more concept, which is uh, there are u versus v graphs as well. I need to go draw. Now some portion is left for this advanced portion. The region wise I told the region wise we'll do later. Although I explained a little bit of region wise to you people, right? Did I?
Yes, sir.
Okay. So question is a point object is placed at a distance of 30 centimeter in front of a concave mirror. Easy question, 10th grade level. Focal length 20 centimeter. Find the nature and location of image. It's a normal 10th grade question. Try to do it. अबे पोछा वोछा मत लगा, ऐसा मत घिस, तुम नॉर्मल ऊपर ऊपर से साफ कर दो, वो कला के लगा देगा। थोड़ा तो दिख रहा है, तो गंदा ही दिख रहा है। वो तो गंदा दिखेगा, वो क्या कर सकता है बताओ। निकाल देते हैं। बाकी का कुछ साफ कर देते हैं। चलो गाइस, टेल मी। And normal 10th grade level question. Now, what is given to you? Object distance is given. Acha, see how I try to do this problem, guys. Dekho, I'll write given. Object distance is basically what? Can you see? Object is placed at 30 centimeter. So I'll leave some space and write 30 centimeter. Why am I leaving this space for? The sign convention part, right? Okay. And the focal length of the mirror is given 20 centimeter. So can you see I have left the space again for the sign convention, right? Abhi don't put it. Okay. Now draw the figure. Let's say I have drawn it over here, and this is the principal axis. This is where the object is there, and this distance is 30 centimeter, and they have given the focal length is 20 centimeter. So object is over here. Now tell me this particular thing, if focal length is 20, then radius of curvature will be, if focal length is 20, then radius of curvature will be 40. So can you see our object is placed between C and F? Now choose a convention for me, please. Can you choose a convention for me? Can anyone choose a convention for me? Whatever you want, not necessary कि what I want. नहीं, तुम बोलो वैसा कर दूंगा. Which convention shall I choose? Tell me positive or negative here.
Negative.
Negative. And here it will become positive. And there is no need for this thing, right? The vertical, because the object is point object, no vertical distances involved. So anyways, so can you see over here the object is placed now towards the left? If the object is placed now towards the left, so can you see left you have chosen as positive, so hence plus. Can you see the focal length is lying towards the left, and left you have chosen as positive, so hence plus. Are you getting my point, guys?
Yes, sir.
So focal length is plus 20, u is plus 30, and you need to find out v. The v is equals to, tell me, v is equals to f into u upon u minus f. Or if you, no, if you don't want this, mat karo. Sir, 1 by v is equals to 1 by f minus 1 by u. That implies 1 by v is equals to 1 by f. Now see very carefully, when I am putting the value of f, I am putting it with sign convention. It does not matter whether it is plus or minus. Can you see, even if it was plus, I am putting it in brackets with this sign, right? Guys, there is a reason for this. It's just to make sure, suppose in case you made any calculation mistake later on, so at least you will be clear from this to this step. When you moved, you just use these brackets, so that you will assume that the sign convention is correct. Can you see I have put the sign convention very clearly, and after this start solving, no problem. After this start solving, right? So 1 by 20 minus 1 by 30 will be 60. 3 minus 2, which will be 1 by 60, and that will be basically your 1 by v. So from here v will be equals to 60. So can you see your answer came with a positive sign automatically? Yes or no? That implies the object image is where? This is where the image is at a distance of 60 centimeter, right? Is it clear? Normal 10th grade question. Is it clear? Chal. Now let's give you a 12th grade question. In the figure shown,
So nature of the image, what do we see?
tell me what will be the nature of image. You tell me. What will be the nature of image? Where is the object placed? The object is placed between.
It's beyond C.
So object is placed between C and F. Object is placed between C and F. Image is formed beyond C. So what kind of nature is it?
Enlarged image.
Real, inverted and enlarged image. But since it's the point object, so the image will also be point image only. Okay. Now,
Yes, sir.
in the figure shown, find the distance from the point P at which, when a plane mirror is placed, when a plane mirror is placed, the image produced by both mirrors coincide with each other. I'll draw the diagram, don't worry. So there is this mirror. This is the principal axis. You need to place the plane mirror on the principal axis at certain distance. This is the concave mirror of focal length 25 centimeter, and the object is placed at a distance of 35 centimeter from the pole and basically the point P, right? Now you need to place another mirror M2 in such a way that the image due to M1 and the image due to M2 shall coincide. So you need to find out this distance. You need to find out this distance x, at which this M2 should be placed from point P so that the images of the object, can you see the object over here? The image of the object coincides from both the mirrors. केक ही केक निकल रहा है। First of all, guys, how will you do this question? If you want to coincide the image, then first find out where exactly this spherical mirror is forming the image, right? Can you see the data for spherical mirror is given to you? This is given, so you can find out where the image will be formed, right? Yes or no? So for mirror M1, acha, convention guys, convention. Let's take the normal, this one. Okay. So for
Yes.
mirror M1, tell me, the object distance, is it positive or is it negative?
Positive.
Positive, how much?
35.
Very good. And what is the focal length?
Positive 25.
Very good. Positive 25. Why did you say positive 25? Because the focus was lying somewhere over here, right? Towards the right, and right you have taken as positive. Everyone understood sign convention, pakka na?
Yes.
Yes, sir.
Okay. So now V you need to calculate the 1 by V is equals to 1 by F minus 1 by U. Shall I use this again or is it fine? As V is equals to F U minus F. So F is plus 25, U is plus 35 and U minus F is plus 35 minus plus 25. Ayana?
Yes, sir.
So from here, can you see 25 into 35 divided by 10? And what is this? Can anyone calculate?
87.5.
How much?
87.5.
87.5. Okay. So basically 87.5 meter away. Are you sure? हाँ. पक्का ना? ये
Yes, sir.
calculation correct है?
Yes, sir.
ठीक है. So now we know that the image is formed where? At a distance of 87.5, right? No. If I have drawn the mirror over here, that implies the image shall form at 87.5 over here. Delete. So from here to here, the distance shall be 87.5 centimeter, right? Yes or no? Now, can you see this is the image 1, and obviously this mirror M2 should be placed in such a way, can you see over here, that this distance, let's say y, and this distance should be both equal. It's because of the properties of plane mirror, image formation by plane mirror, right? So can you see if this mirror is placed exactly at the midpoint between O and where the image is formed, then can I say this particular thing? Both the images due to this mirror and this mirror forms at the same place, right? Can you people imagine this particular whole question? Can you imagine this scenario? Yes or no? Is this concept clear, guys? Now you just basically need to find out the distance. Why? Ho jayega ab. And you see this whole distance is how much? 87.5. This distance is how much? 35. So can you see what is this distance? So can I write from the figure 35 plus y, basically that is 2y is equals to 87.5. So 87.5. Yes or no? So from here, can you see 2y is equals to 87.5 minus 35? Yes, please. I need your help again. 2.5 and guys, 52.5, right? Is basically 2y, and from here y will be equals to 26.25. Yes or no? So basically the value of y is how much? 26.25 centimeter. So basically this distance is 26.25. But is this the answer which we want? The question said what is the distance of the mirror M2 from point P? So basically you want to find out the distance from here till here, right? So what will be the answer, guys?
35 plus 26.2.
From P it will be 25, nahi 35. The distance was 35, no? Object
Yes,
distance
sir. 35.
plus 26.25. So basically whatever this is, that's the answer. Is this clear? Shall I give you next question?
Yes, sir.
A converging beam is incident on a concave mirror of focal length 40 centimeter such that the intersection point of these incident rays is located at a distance of 40 centimeter on principal axis behind the mirror. Now the question is find the location. हाँ ठीक है, nature of image, location and nature of image. So basically it's a question for virtual object. So they have given you a concave mirror and school syllabus में ये वाला question, by the way. This question is from NCERT. They have not used the term virtual object very cleverly, right? है ना? But can you see they have given कि there are two incident rays which are incident on a mirror. So these are your incident rays. This is your incident ray, and they have cleverly mentioned this particular thing that the intersection point of these two rays is at a distance of 40 centimeter behind the mirror. So basically this is your object and this object is basically virtual. Can you see over here, guys? The
Yes,
incident
sir.
rays are converging. So whenever incident rays are converging, object is virtual. So now after reflection, what will happen? These light rays will pass through one particular point, and you need to find out what is the focal length of the mirror. The mirror's focal length is 40 centimeter, right? So basically the object is placed at a distance of 40 centimeter behind the mirror. Now tell me where exactly the image will be formed. So convention, tell me which convention, what shall I take? सात्विक क्या लूँ भाई, कोई सा भी convention, which, tell me whatever convention you will say, I'll take. Hello, Satvik is here. Are you here? Satvik is here. हाँ, Satvik is here. Yes, guys, anyone? Tell me any convention here. जल्दी बोलो. We don't have that much time.
So it'll be plus 40. You will be plus 40.
You will be plus 40. What will be F?
F will also be plus 40.
Wrong. The focus. Can you
No.
see the concave mirror I have taken like this? The focus lies somewhere over here.
It'll be negative. Yeah, yeah.
Negative 40.
Okay, yeah. Sorry.
And V is what you need to find out. So 1 by V is equals to 1 by F minus 1 by U. So 1 by minus 40 minus 1 by plus 40. So which will be equals to minus 1 by 40 minus 1 by 40. So minus 2 by 40, which is minus 1 by 20. And so from here, V is equals to minus 20 centimeter. So can you see the object is formed, the image is formed at a distance of 20 centimeter. And can you see if it is forming in front of the mirror that this image will be? What kind of image will this be? Guys, can anyone tell me what kind of image will this be? Can you see the rays are actually meeting?
Real image.
So the image will be real. Is this clear? Is this clear, guys?
Yes, sir.
चलो एक क्वेश्चन और दे रहा हूँ. ये again one question I'm giving you as a homework question, 10th grade level का. Reflection is much more easier as compared to, you know, refraction. So anyways, Find the distance from a convex mirror. Please remember all the distances are measured from pole, right? है ना? So I'm asking the distance from pole only. Of focal length 60 centimeter, where an object of height 12 centimeter should be placed so that its image is produced at 35 centimeter from the mirror. Also find the height of image. So it's a typical 10th grade question, just including magnification formula as well, right? So please do it as a homework. I don't have the answers to the problem, but still. Next question. Please write it, then I'll do the next question. So when his face was at 40 centimeter from mirror, find the focal length. Karo, do this now. Guys, all the ray diagrams for virtual object I'll give you later on when we'll be done with the whole school thing. Right? After completion of chapter, I'll tell you the number of pages to leave in this. Okay? How many pages
Yes,
to leave
sir.
in the case of reflection for JE portion or NEET portion? And we'll move to refraction. First of all, if a man is shaving, then tell me what kind of image will he see in the mirror? Will he be able to shave with his face inverted, guys?
No, sir.
Anna, so basically what kind of image should be found?
Erect.
Erect image with respect to object. So if a erect image is formed with respect to object, then tell me whether magnification will be +2 or -2. Magnification, will it be +2 or -2? It will be +2, right? Positive signs means what? The image is erect with respect to object, and negative sign means what? The image is inverted with respect to object, right? And 2 times is basically the magnitude. To magnification given is basically +2, and this is basically equals to minus of b by u. So from here, can you see over here, +2 will be equals to what? Minus of b by, and where is the object placed? Object is placed at a distance of 40 centimeters. So I'm supposing this is the same case like this. The object is placed somewhere over here at 40 centimeter, and its image should be formed virtual and erect behind the mirror. Can you see? Then only it will be able to see inside the mirror, right? So U is basically minus 40 centimeter. So from here, kata kata, B is equals to plus 80 centimeter. So now you got V, now you got U, and I think you can calculate F easily. Right? हो जाएगा? हो जाएगा guys? Guys, will it be? ठीक है. Now next question, and this is the main type of question which which people ask in 12th grade. Suppose there is a concave mirror, and let's say there is another convex mirror. Can you see one concave mirror M1 and one convex mirror M2? They are placed in such a way that the principal axis of both the mirrors coincide. Principal axis of both mirrors coincide. So they have been placed like this in such a way that the principal axis of both the mirrors coincide. This is the first pole of the mirror. This is the pole of the second mirror. First pole cap. This is the pole of the first mirror. This is the pole of the second mirror. The focal length of first mirror, this mirror is basically 20 centimeter, and the focal length of this thing is basically how much? 30 centimeter. The distance between the poles of the mirror is 50 centimeter, and the object is placed exactly midway between them. So basically OP1 should be OP2, although it's easy to calculate. Hai na? Object placed exactly. This is the question given to me, but I'm not writing the whole question. I'm just explaining the situation. Okay. So object placed exactly midway between M1 and M2. So this is given to you, and OP1 and OP2 will be equals to how much? 25 centimeter, right? Ayana, people, itna clear hai abhi as of now? Is the question clear till here? Now, now, find the location and nature of its image, nature of the image formed if nature of the image formed after two successive reflections first from M1 and then at M2. Try to solve it. I'll be waiting your answers. I'm giving you 3 minutes to solve this problem, and your time starts now. I'm not putting a timer, I'm just doing this. So this is the question in front of you. Try to do it. I'll be back in 3 minutes, and I'll ask directly the answer. Yes, guys, are you done with the question? Anyone got the answer? Hello, hello, hello. Anyone got the answer? I have read, given a hint as well in the screen. The answer somewhere. The answer is 75 centimeter. How? Dekho. You'll learn something new concept. First of all, tell me where the reflection is taking place first. Guys, can you tell me where the reflection is taking place first?
Mirror M1.
At M1, right? So, kara do reflect. Take a light ray. I'll give you a next level question after this, है ना? This question taken to the next level. So ये लो. This is a light ray, है ना? Tell. One light ray is going like this. Let's say another light ray will go like. Whenever it's a point object, take this. It's much more easier to do. Right? So this is your first ray, which is getting reflected back from the mirror M1 first, right? So can anyone tell me where exactly the image will be formed of this particular thing? First of all, we'll decide a sign convention. Let's say positive is over here, negative is over here, positive is over here, and negative is over here. So for first mirror, can you see first mirror say reflect? Okay, one light ray will go like this straight, and another light ray will converge where the first image is formed, right? So for the first mirror M1, what is the object distance? What is the object distance, guys? With sign convention, you need to tell. Na? For the first mirror, what is the object distance?
Plus 25.
Very good. Plus 25 centimeters. What is the focal length of the first mirror?
Plus 20.
Plus 20, correct. So, can we calculate the V? We can apply mirror formula, right? So, either you can calculate like this or you can do it by the conventional method 1 by V equals to 1 by F minus 1 by U and solve. It's up to you. So, this will be plus 25 plus 20 multiplied by U is plus 25 minus plus 20. So this will be 25 into 20 divided by 5, which will be 100 centimeter, right? Can you see, guys, this thing which you are getting is positive. That implies where will the image form? The image will be formed where will the image be formed? The image will be formed at 100 centimeters. So basically, this is the image formed by the first mirror. So the light ray will go like this. But can you see, before it reaches I1, it will get reflected back? Yes or no? So can you see again a case of virtual
Virtual
object?
image.
The image which is forming for the real image is which is forming for M1 is acting as a virtual object for, yes or no? This is the incident ray, this is the incident ray, this is the reflected ray, and this is the reflected ray. So can you see the reflected ray is going like this? Yes or no? Yes or no? So we can say this particular thing, image for mirror M1 A real image I1 is formed at a distance of 100 centimeter from P1. But but we can say this particular thing, the mirror M2 comes in between. Before this image I1 is formed, will mirror M2 come in between, right? Due to which now the image I1 will act as a virtual object for mirror M2. Okay, so basically image I1 is acting as the new object. Bhale say it's a virtual object, doesn't matter. But still, can you see over here, whatever image is formed with the first optical instrument is acting as an object for the second optical instrument, right? So whenever multiple optical instruments are involved, then image due to first acts as object for second, and so on. If there are many more instruments involved, then what will happen? Is this note clear, guys? Guys, is this clear? Again, this thing is not given in any books. It's just learning by experience, and I'm sharing the experience with you people. Except, So for mirror M2, now can anyone tell me where exactly the object is located for mirror M2? Now, if I'm talking about mirror M2, all the distances will be measured from pole P2, right? So can you see for image for M2, the object is located where? At a distance of? At a distance of? This
50, right?
yes, this was 100 centimeter, right? This was 50. So this will be also 50. The object is located towards right at a distance of 50 centimeter. So right 50 centimeter. Can you see? Did I change the convention? The convention is still same. No change in the convention, right? Now, can anyone tell me where will be the focal length of this thing? What will be the focal length? 30 centimeter plus or minus? Focal length will be plus or minus.
So plus.
Why plus?
So because we are taking distance from the pole.
So why plus? Because the focus of this mirror will lie somewhere over here, right? Towards the right.
Yes,
So
sir.
that's why we are taking this as plus 30. Now again, u and v is f is there. V is equals to fu upon u minus f. F is plus 30. V is plus 50. U minus f. Right? Yes or no? So this will be how much? 30 into 50 divided by 20, which is plus 75 centimeter. So where exactly the final image is formed? The final image is formed at 75 centimeter. मतलब basically यहाँ पे. Are you getting my point? This is where the final image is formed at a distance of 75 centimeter. So ultimately what happens? This light ray in it goes like this. It again strikes over here, again strikes over there, but can you see over here? ऐसा कुछ. Now you understood what exactly I meant. So this is the reflected ray from the second mirror. Is this clear, guys? Although you don't need to see that, your answer will be what? Where is the final image located? At a distance of 75 centimeter behind mirror M2. The image will be virtual because it is forming behind the mirror, right? Is this clear? Is this clear?
Yes, sir.
Okay.
Yes, sir.
चलिए ठीक है. So that's it for reflection. I'll give you one more homework problem. है ना? Try to do this at home. I don't know the answer for this, so don't ask. It's just for practice I'm giving you. Can you see two concave mirrors? Guys, can you see two concave mirrors?
Yes, sir.
Now what happened to these concave mirrors? You know, the distance between them is 1 centimeter. Distance between their principal axis. Can you see the principal axis are not same? The distance between the principal axis is 1 centimeter, and the distance between the mirrors is, let's say, 50 centimeters, and an object is located at a distance of 20 centimeter from mirror 1. Again, first reflection at first reflection at mirror M1 and then M2. Now the question is, if the focal length of this mirror is 20 centimeter, 20 तो ज़्यादा हो जाएगा, let's say 30 centimeter, and the focal length of this thing is 50 centimeter, then find the coordinates of the final image after two successive reflections. Obviously, I've given only two, no? First reflection M1, then at M2. Find the final coordinates of the final image of the system considering P1 as origin. Okay? So consider this as the origin point, and you need to find the final coordinates of the whole thing. Is it clear? Is it clear, guys? Kar loge?
Yes, sir.
Try this
Yes.
question at home. It's good. Although I don't know the data I made up. I saw this question somewhere, but data is all made up. And I don't think so you'll need anything else apart from this. So yes. Anyways, So this is the last thing, and now you can leave one, two, three, four,
So can you show
and
the
five.
question again?
5 pages, guys. Leave 5 pages for JEE neat stuff. We'll do some more questions, and we need to do velocities and all as well. We need to do three more things: longitudinal magnification, aerial magnification, velocity of object, velocity of image. Again, the same thing, and U versus V graphs. So leave 5 pages for it. Sach, by the way, tell me this particular thing. Do you have U versus V graphs in NCRT? Did your teacher draw U versus V graphs?
No.
No, na. So फिर
No.
that's it. That's in J neat stuff. Then leave 5 pages, sir. Guys, leave 5 pages for reflection, and then write the next heading: refraction. Refraction is big, very big. But again, refraction has certain derivations in it, है ना? What अभी तक what we have done? We have done two derivation. One was for magnification formula and one was for mirror formula, right? Guys, ray optics. Is this clear? We'll do the JEE neat stuff later on.
Okay, sir.
Please write the next heading: refraction. Now everyone understands what a refraction of light is, right? What is refraction of light? It is the phenomena, or basically, suppose. Do you remember this thing? Whenever a pencil stick pencil, if you have, and if you dip that pencil in water, then it looks a little bit bent, like this. Yes or no? Yes or no, guys? Have you ever tried this at home?
Yes, sir.
है ना? So basically, why is it looking bended, a little bit bent? It's because whenever light ray, it travels from one medium to another. Can you see here? It was air, and here it is water. So whenever light ray, it travels from air to water. Whenever it goes from this particular thing, it bends a little bit. This phenomena is called as the refraction of light. So whenever a light ray incident obliquely. What do you mean by obliquely? Oblique incidence. मतलब at some angle, okay? It shouldn't be normal incidence. So whenever a light ray incident obliquely on a boundary between two media, on a boundary between two media, whenever a light ray incident obliquely on a boundary between two media, then the light bends from its original path. This bending phenomena, bending of light when it changes its medium, when light bends on changing the medium, is called as refraction of light. Please write it down. In different mediums, the speed of light is different. We all know this particular thing, that the speed of a wave, it depends on the medium, right? And light is a wave, right?
Yeah.
When we talk in terms of wave optics and all. So in different mediums, the light of the speed is different, and uh, their speeds, which we'll learn later on, their speeds can be related with something called as the refractive index of the medium, right? So later on we'll relate the speed with refractive index of the medium. Also this particular thing, acha, tell me this particular thing, this bending phenomena will be shown only when the light is incident obliquely, right? What will happen in the case of normal incidence? Will the speed change? In the case of normal incidence, the light ray passes undeviated. The you won't be, the bending won't be visible, but still the speed will change. Yes or no?
Yes.
Now, when it bends from its path, there are two cases. Suppose this is the medium boundary, this is the medium boundary, and let's say this is the light ray which is coming. Can you see the light ray incidenting? Control C, Control V. Can you see the light ray incident obliquely on both the cases? Yes or no?
Yeah.
Can you see over here? This would have been the original path. This would have been the original path, right? So this is your incident ray, which is incidented obliquely on this medium boundary. So basically this is medium 1 and this is medium 2. Similarly here also medium 1 and here also medium 2. This line which I have drawn, shall I draw it with a different color? Okay, it's fine. This line which I have drawn is basically what? What is this?
The normal.
The
Well,
normal at the point of incidence. Where is the point of incidence? This is the point of incidence, right? Yes or no, guys?
yes, sir.
No. In one case, the reflected ray bends away from the normal, और पहले इधर towards कर देते. In one case, can you see? This was the normal and this was the original path. The light has bended towards the normal, right? So case one is when the light reflected ray bends towards normal. And in one case, what will happen? Guys, in one case, what will happen?
Away from the normal.
The reflected ray bends away from normal. So in one case, this will be the case. Can you see reflected ray bent like this? Yes or no? Away from the normal. This was the normal, so away from the normal. Towards the normal, so towards the normal. Are you getting my point? Is this clear? Sir, when does it bends towards the normal? When does it bends to, uh, this thing? When does it bends towards the normal? When does it bends away from the normal? It all depends upon these mediums. है ना? Whenever light ray is traveling from a optically rarer medium to a optically denser medium, we'll talk about optical density later on when we'll be discussing absolute refractive index and all. Or I'll write this so over here. And similarly, whenever a light ray goes from a optically denser medium to a optically rarer medium, then it bends away from the normal. Clear? In both the cases, this is the angle of incidence and this is the angle of refraction now. Angle R is basically the angle of refraction. The angle between reflected ray and normal is basically called as angle of refraction, right? सबको पता है ना?
Hmm.
Now please remember, whenever we talk about optical density, basically it's a parameter which is responsible for the speeds of light. Basically refractive index only, but we can term it in more technical way. So a medium is said to be optically denser when the speed of light is low, and if I say optically rarer, that implies the speed of light is more. So in an optically rarer medium, the speed of light will be more as compared to an optically denser medium, right? So always there will be a comparison between two mediums, right? So suppose in the first case, if I say the velocity of light here is v1 and the velocity of light here is v2. Similarly, here it is v1 and here it is v2. Can anyone tell me what will be less and what will be greater? What will be the relation between the velocities? Velocity 1 will be higher in the case of when it is going from rarer to denser, and here it is going from denser to rarer. So here v1 will be less than v2, right? Is this clear, guys? Always remember, density is related with speed. If more dense, less speed; less dense, more speed. Clear? And also please remember, this optical density is always relative. You compare between two mediums, this medium is much more optically denser as compared to this medium, right? So please remember, optical density is a relative term. It's a relative term, always used to compare between two mediums. Is this clear? And this optical density is given with the help of refractive index of the medium. Refractive index. Please write the heading. Today will be just, at least we'll do the basics of everything, and then we'll do refraction is bigger as compared to, but I will try our best at least kuch we will be able to do it. I'll try my best ki JE level, NEET level, we'll do it later on, but at least the school level we'll try to finish. So refractive index. What is refractive index, guys? There are two different types of refractive index. One is the absolute refractive index, denoted by mu or n. There are two formats in which you define the refractive index. So the refractive index of any medium is equal to speed, the ratio of speed of a light in vacuum. Okay, what is the spelling for vacuum?
That's correct, I think. UUM.
Okay. The speed of light in vacuum to the speed of a light in the medium. So which is basically C by V. Speed of light is given by C and this is given by. So the absolute refractive index of a medium is basically the velocity of speed in vacuum. Oh, sorry, speed of light in vacuum, and this is the velocity of the medium. Please remember, C is the constant, right? And what is the value of C? Approximately 3 into 10 to the power 8 meter per second. It's constant speed of light, and so from here clearly you can say is inversely proportional to velocity. More the speed, less will be the optical refractive index. More velocity of the medium, or in spite of writing that, if velocity of medium increases, the refractive index of the medium decreases. Also, the optical density also decreases. Is this clear? And vice versa. Guys, is this clear? Is it clear, guys? Please remember the SI unit won't be there. Dimensional formula won't be there because it's a ratio. Whenever it's a ratio, then it's a no dimension, no unit. है ना? The refractive index, absolute refractive index of air, we take it as 1.0003. The refractive index of vacuum, we take it as 1, exact 1. The refractive index of water, we take it as 4 by 3 or 1.3333. The refractive index of glass in general is taken as 3 by 2, which is 1.5. The refractive index of diamond is 2.42. Acha guys, please remember what do you mean by this particular thing? Refractive index of air is basically this. That implies the speed of light in air is 1.0003 times less as compared to vacuum. This refractive index of water is basically 4 by 3, so the speed of light in water is 4 by 3 times less of vacuum. Are you getting my point? 1.5 times less of vacuum. Are you getting my point? Hello? Hello? Now, the second type of refractive index is basically relative refractive index. Acha, guys, you can either write it as mu m or you can either write it as nm. It's up to you, whichever convention you want to follow. Here, a little bit tricky will be there. A relative refractive index, it basically compares between two different media. Hai na? So there are two different notations. We write it like this. One is basically mu to 1 and another one is basically n to 1. Whenever we have mu to 1 notation, we read it like this. Mu to 1. And when this notation is there, we note it, read it like this. Are you understanding this particular point? Read it like this. N to 1. So n to 1, mu to 1. Are you getting my point, guys? So these are two different things. They both are what? They both represents the relative refractive index, or basically refractive index of medium 2 with respect to medium 1. Is this clear? Both of them, they represent what? The refractive index of medium 2 with respect to medium 1. Acha, tell me, if it is given like this, then how will you read it? Refractive index of medium 1 with respect to 2. Are you getting my point? First go towards this and then here. And if it's like this, then the refractive index of medium 1 with respect to 2. Sometimes, question will be given like this. Refractive index of air with respect to glass. So can you see air with respect to glass? Are you getting my point? So you'll read this first and then this first. If it was given like this, air with respect to glass. So air with respect to glass. Are you getting my point? ये सबको पढ़ना आया? Everyone understood how to read it first, है ना?
Yeah.
Yes, sir.
The way you read it, that is how you define it, है ना? So if I have refractive index of medium 2 with respect to 1, so this is basically what? The absolute refractive index of medium 2 with respect to the refractive index of medium 1. So basically this mu to 1, or basically refractive index of medium 2 with respect to 1, is basically 2 with respect to 1. And please remember, can you see over here? This will be C by V2 divided by C by V1, and it will be equals to V1 by V2. So sometimes people define it in terms of the velocities as well. Refractive index of medium 2 with respect to 1 is basically mu2 by mu1 or V1 by V2. Can you see they were inversely proportional? And so that is why inverse relation. Is this clear? Is this clear, guys? This is your relative refractive index. Is it clear?
Yes, sir.
Note, refractive index depends upon first the nature of the medium, and I'm talking about absolute refractive index for example, suppose, so it depends on the nature of medium. Obviously, different mediums have different optical densities, right? Second temp is basically temperature. Always remember, if temperature will increase, then refractive index decreases. I don't know the reason why, but yes, it does. Then third is, it also depends upon wavelength of a light. And which light I'm talking about? Wavelength of incident light, obviously. There is one equation that refractive index is equals to A plus B by lambda square, where A and B are constants, and this equation which I have written, this is called as Cauchy's equation. So can you see over here, from here, mu is inversely proportional to lambda. If lambda will increase, this term will decrease, and if this term decrease, automatically mu decreases, right? Yes or no? If lambda is increased, then mu decreases, right? But it does not decrease directly. It goes according to this Cauchy's equation. This A and B are constants which are dependent on material of the medium and temperature. So basically, the first and second point I have included in this equation. Is this clear? Is this clear, guys?
Yes, sir.
So always remember कि suppose if you have lambda, which is basically what do you know this fact or not? First of all, tell me. The wavelength for red is more as compared to the wavelength of violet. Do you know this? That is why we are able to see
Yeah.
red color
See
from a very
red
large
stop
distance.
signs. Yeah.
Red, है ना? So ये reason सबको पता है, I am assuming. So please remember, if mu lambda is red is greater, then can you tell me this particular thing? Mu red will be less as compared to mu violet. That implies कि if there is a medium in which you have incident, let's say red light and let's say violet light at the same angle, है ना? At the same angle of incidence. Can you tell me in this case and this case, let's say it is bending towards the normal, this angle of reflection is R1, this angle of reflection is R2. Tell me which will bend more. If please remember, more the refractive index, the more it bends from its original path. I told you about this particular thing, that it bends from its original path, right? This bending, can you see this bending? No, sorry. More the refractive index, more it will bend from its original path. Yes, correct. correct. Sorry, I got confused. Okay, is this clear, guys? Till here? So the refractive index of
Yes,
violet
sir.
is basically greater than this thing. Acha, yellow is basically considered as the average color. Yellow is considered as average color. What do you mean by average color? Whose wavelength lies exactly in midway in the visible range. So that's why it's called as average color. Okay, is it clear, guys? मैं इतनी नहीं खाएगा, चॉकलेट का शौकीन नहीं है। So is this clear, guys?
Yes, sir.
Shall we discuss the next thing? The next
Yep.
thing is basically the law of refraction. Is it fine if I take 10 minutes more?
Yeah.
First is the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane called as the plane of incidence, right? Yes or no?
Hmm.
This is I, this is R. So always remember, if this is your incident ray, this is your reflected ray, and let's say this is your normal. Okay. So again the same thing, a unit vector across incident ray, a unit vector across normal should be equals to here it is a little bit different. Huh? Mu1 is basically the refractive index, absolute refractive index of medium 1, and mu2 is the absolute refractive index of medium 2. So mu1 is equals to this, and mu2 is equals to mu2 into. So this is the mathematical form. Also not there in your school syllabus, but it's there. Is this clear, guys? Shall I बनाई देता हूँ diagram में? So can you see incident rays like this? Acha, it's up to you guys. Do you want to take that direction as normal or this direction as normal? It's up to you. But generally, people take this as the normal. So n cap is in this direction. IR cap is in this direction. And this angle is I. Do you remember? This angle is I. So this angle is I, right? So this is I. Then the angle between them is pi minus I. And here, this is the reflected ray. And this is the normal. The angle between them is r. So this is pi minus r. You can take either this as normal or you can take that as the normal. It's all up to you. क्योंकि sine of I and sine of pi minus I, is it one and the same thing? Yes or no?
Yeah.
Yes. And sine of r and sine of pi minus r, 180 minus r is also the same thing. So generally people take this, but it's up to you. You can take anyone. The second thing is the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. Okay, that this thing is basically called as Snell's law, but we'll be never using it like this. Suppose this is r, this is mu1, and this is mu2, है ना? So according to Snell's law, it says that the ratio of sine of angle I to the sine of angle R is equals to mu2 upon mu1, and this is basically mu2 with respect to 1. You remember? Refractive index of medium 2 with respect to 1. Never ever remember it like this. It's okay if you write it from school perspective. If you write it with school's perspective, it's correct. But whenever we'll have to apply it in competitive exams and all, never use it like this. Use it like this. Can you see what is sine of angle I multiplied by mu1? So mu1 into sine I should be equals to mu2 into sine r. Can I write it like this? Can I write it like this, guys? And can you see
Yes.
this is constant? So you can in competitive exams you can write the product of sine of the angle made by light ray with normal. Can you see the product of sine of angle made by light ray with normal in that medium and the refractive index of that medium? So basically product of basically sine of angle of this and the refractive index of that medium is constant. Example, suppose I have a light ray which I incidented in at an angle of 60 degree, and let's say it goes at an angle of 30 degree, right? Yes or no? The refractive index of this is, let's say, air, and this is, let's say, water. I'm just giving you for example, है ना? The actual values may not be equal to equal in this case because I don't have the data with me. But can you see over here what is the refractive index of air? 1 multiplied by sine of, can you see what the angle made by the normal with the ray? What is it? 60 degree, right? So sine 60 should be equals to water 4 by 3 multiplied by sine of 30. Although I know this is not equal, but can you see how exactly I applied? Can you see, guys, this angle 30 degree was with normal in the water, so I wrote with the normal in the water with the refractive index. Similarly, this 60 was with normal in air, so with normal in air. Are you getting my point? So this is how you apply it. Is this clear?
Yes, sir.
चलिए ठीक है. The values may not be equal. These values may not be equal in this example which I have given because I don't have the data with me, but you understood this particular thing, I guess. So anyways, so this is it. That's it for today's class. In the next class we'll see some applications and the numerical part. I told you, the numerical part will start. Total internal reflection will be there. Lots of things are there in this thing. Refraction through conservative lateral shift. So in the next class we'll continue further.
Okay,
Chal.
sir. Sir, can I ask a question if you're not getting too late?
बोलो.
I know मैं आपको बहुत ज़्यादा आजकल doubts पूछ रही हूँ. I just hope I'm
It's
not.
okay, no problem.
Yeah. Sir, I was doing a question and उसमें एक हमको circular rim दी हुई है and उसके अंदर magnetic field है and there were like a series of questions and by the end of which we came to the conclusion that there's a magnetic field generated which is in the minus k direction or downwards or into the plane, and then they asked us how that affects omega. So what will be the direction of omega for the rotating wheel? So how will I
बेटा
find that?
ध्यान रख, अब ओमेगा को अपोज करने के लिए you'll always induce a current in such a way that this omega will get opposed because that motion is causing the EMF to induce, right?
Yeah.
So वो मोशन को रोकने के लिए कौन लगेगा? एक इंड्यूस्ड टॉर्क होगा. That induced torque will be with the help of what? Bina sin theta, and that
Yeah.
I will be the induced current in that case. So try to find out the direction of that induced current using Lenz's law and then apply torque.
Okay, so I already have the direction of the current, and then
हाँ,
from Bina sin theta,
from
I'll
Bina sin
find
theta. Correct.
omega
Bina sin
का
theta is
direction.
basically what? M cross V. है ना?
Yeah. Yeah.
That is with the help of that find out torque. और वो
And
opposite.
torques I can find the omega.
हाँ,
Fine.
with the help of torque, that torque will be opposite.
Okay, got it.
और कुछ?
No, that's it.
चलिए ठीक है. Okay guys, thank you very much. We'll see you again.
Thank you, sir.
Okay, bye bye.
Thank you, sir.
Bye bye guys. Good night.
Thank you, sir.